Hi everyone, my name is Gallant Tsao, and this will be my quarter two elevator pitch for the Capstone. Our group's topic is called the analysis of point cloud data using optimal transport, which has a large range of applications, including plant phenotyping for detecting stress, motion capture, and even color transferring problems. Now, to model a point cloud, we can imagine, let's say, we have a maze plant in which we want to monitor its growth. What we do is we take intervals, let's say day one, day two, etc., and take roughly 100,000 points on the maze plant uniformly each day. And this will be our point cloud data, which is a multivariate time series that evolves through time. Optimal transport seeks to find the so-called optimal transport map between any of these two point cloud data. By modeling these point cloud data as probability distribution. So for example, if I want to model how my maze plant grows from day 3 to day 4, let's say, then I'll take a point cloud on day 3 and I'll take a point cloud on day 4 and try to find the map that maps the points on day 3 to points on day 4 such that we try to minimize something called the transport cost. So ideally, you will want something like points on day 3 and points on day 4 near the leaves should be around the same location. And optimal transport is a mathematical tool seeking to solve these type of problems. Now, the specific problem that our subgroup is interested in is something called preconditioning for optimal transport, which is something that you may or may not heard of in your daily machine learning applications. So when we're trying to, let's say, train a linear model, what we do is that we standardize the columns by subtracting the mean and standardizing by the variance. So what we're doing here for this project is really similar because our group thinks that although optimal transport algorithms do not perform well in high dimensions, we have ways to improve the performance of these algorithms by first doing some preconditioning on the data itself so that we could try to improve the performance of optimal transport algorithms. So we'll compare the performances by measuring effectiveness of the runtime of current optimal transport functions in which you have access to on an online library called Python Optimal Transport. Now, if time permits, the another goal would be to try to find counterexamples in real life in which our approach for preconditioning does not work well in practice. In that way, we could identify, let's say, which problems in in point cloud data can we use preconditioning on, and which point cloud data can we not use preconditioning for optimal transport on, and hopefully try to boost the overall performances of current optimal transport algorithms.